All right, IM2 density. Just give you a heads up, there's going to be a lot of converting units in this thing. So you need to be really good at converting units, whether that's picket fence method or some other method that you've learned, but you need to have a strategy for converting units, like for example, centimeters to meters or, feet to inches, vice versa. You need to have a strategy for that. Let's get right into it. Objective: students will be able to solve problems concerning real-world situations using their knowledge of volume, surface area, and density. Density, what is density? Well, density is the ratio of mass to volume of any object. Therefore, the formula is just D equals M over V. I like to use this flux capacitor method though, because sometimes you're not always going to find density. If you're finding density, sure, just mass divided by volume. But maybe you're finding mass. So what you could do is you could cover up the M, and then you'd have dV. So that means your equation could be written as M equals D times V. Or let's say you're trying to find volume, you cover up the volume, you have mass over density, and so that means your equation could be volume equals mass over density. And so this little trick lets you have all three of these versions in the formula in one method. I call it the flux capacitor method. And we actually use it for lots of different things that have three parts to it. All right, let's get right into it. Big thing here, remember, units matter. So you need to read through the units and make sure that you're putting units in your answer. And if you have like multiple units of like mass that are different types of units, you're going to need to get them all the same unit. We'll see that down here in example 2 in practice 2. But this first one's pretty straightforward. It just says calculate the density. Okay, well, again, flux capacitor, cover my D equals M over V. So I'm going to start with D equals M over V. D equals mass over volume. Okay, what's my mass? Well, my mass is 64,900 kilograms. They gave it to me right here. And what's my volume? My volume is 5.9 cubic meters. I'll go ahead and do that in blue, 5.9 cubic meters. So literally all I do here is divide, okay? And if I divide 64,900 by 5.9, I get 11,000 kilograms per cubic meter. And that's fine. It's a little big, and there might be some other units we could use to make this number a little bit smaller, but that's fine. They didn't specify units, so we can leave it just like that. All right, so in practice 1, very similar problem. I want you to find the density, and I'm just going to go ahead and give you a hint. You don't have to worry much about units because your density in this situation will be in pounds per square feet. So you don't have to worry about units here so much as long as you keep track of them. Go ahead and give that a shot. Check back when you're ready to check your work. Okay, your mass here is the 540 pounds. Mass is always going to be some kind of weight unit. And so you just do 540 pounds because mass over volume equals density over 12 cubic feet. 540 divided by 12 is 45. So there's your answer in pounds per cubic feet. Again, we have to have units in our answer. Very, very important here. All right, speaking of that, let's get into example 2. Now, this one's going to take a little bit of time to explain because there's a lot going on. It says a piece of metal has a density of 270 kilograms and a volume of 200 cubic centimeters. So we have a density. I'll do it in red. Density is 270 kilograms per cubic meters. And we have a volume of 200 cubic centimeters, and they want us to find the mass. Okay, first of all, when finding the mass, if I use the flux capacitor, right, I'm going to write it over here, dmv. If I was to cover up the mass, I'd have D equals, or D times V. So I'm going to write my little mass equation as mass equals density times volume. All right, but there's a problem. Because we said this earlier, our units need to match. These units are cubic centimeters, that's a volume unit, and these are cubic meters. They do not match. So we need to get everything in the same units. And this is where it might get a little tricky here because you really need to have your picket fence method down or maybe some other strategy down. So I'm going to go ahead and tell you what units would be best for this problem. And the best units to answer this problem is actually in grams. And actually, if you want to skip ahead over to practice 2, I'll tell you the best units to answer this one over here is going to be in cubic centimeters. Okay. Just gives you a little hint. All right, so since I want this thing in grams, I know that seems crazy that I would want it in grams because grams isn't even here. But trust me, you don't want it in kilograms. You're going to get a tiny decimal with a whole bunch of zeros, and that's a very inaccurate way to describe your mass. So really the best way is to do this in grams. We're going to convert everything to either grams or cubic centimeters. When it comes to density, we tend to use kilograms with cubic meters, and we tend to use grams with cubic centimeters. It doesn't have to be that way, but maybe you'll understand why after we go through this problem. Okay, so before I do anything, let's try to convert everything to one consistent thing. We're going to use cubic centimeters, so I want to get rid of that. I don't want that to be meters. I want that to be in cubic centimeters. And we're going to use grams, so I also want to get rid of that. So all I'm going to do is I'm just going to play with my density here for a little bit. So let me come over here and just kind of show you what I'm going to do. You might need a little extra space. Sorry I didn't provide more space. But my density right now equals 270 kilograms. Technically, we could say over 1 cubic meter, because that's what that means, per 1 cubic meter. But I really want my density to be in grams over cubic centimeters. So here's what I do. I'm going to start with grams, and I'm just going to ask myself, what do I know about grams? Well, I know, and hopefully you know this too, that there's 1,000 grams in a kilogram. If you don't know that, you should probably Google that, learn that. But the metric system is pretty easy. Kilo literally means 1,000 grams. So kilograms, 1,000 grams. Okay. Well, what else do I know about kilograms? Well, I know that I have 270 kilograms per every 1 cubic meter. Okay, so what do I know about a cubic meter? That's my next question. And what do I know about cubic meter and cubic centimeters? Now, we should have talked about this already in class when it comes to volume, but let's just think about what that means. A cubic meter means a cube of a meter on every side. So this would be 1 meter, this would be 1 meter, and this would be 1 meter. And so you have 1 times 1 times 1, which is 1 cubic meter. But what's a meter in centimeters? Well, isn't this 100 centimeters? And isn't this 100 centimeters? And isn't this also 100 centimeters? Since that's the case, we need to think about what would that be? Well, that would be 100 centimeters cubed equals 1 cubic meter. If you cube 100, you get 1,000,000. So let's just talk about that real quick. We're going to get 1,000,000 here. I don't even have space enough to write 1,000,000. But just know that's 1,000,000 cubic centimeters. Okay, I could do all this math now. All I have to do is recognize that, okay, I have kilograms on top and bottom, they cancel out. Cubic meters, top and bottom, they cancel out. What would I be left with? I'd be left with grams over cubic centimeters, and I said that's what we want. So we're converting this whole thing from kilograms over cubic meters to grams over cubic centimeters. So all I have to do is do 1,000 times 270 times 1, so I don't really have to think about that, divided by 1 times 1 times 1,000,000. So I can really just do this times this divided by 1,000,000. I'm going to go ahead and do that in my calculator and get my new density. So my new density would be 1,000 times 270 times, or divided by 1,000,000, which is just a 1 with 6 zeros, and I get 0.27 grams per cubic centimeter. Now, that may seem funky, but it's going to make our next step really easy, because if you go back over here, remember, at the end of the day, we're trying to find mass in grams, and I now have a density that uses grams, and it matches my volume, which is in cubic centimeters. So let's go to this equation. Mass equals density, which I know is 0.27 grams per cubic centimeter. And I'm going to just simply multiply that by my volume, which I already know to be 200 cubic centimeters. All right, this is pretty easy to do. When I multiply these together, hopefully recognize cubic centimeters cancel out. So 0.27 times 200 gives me a nice, easy number of 54 grams. Okay, if I would have left this in kilograms, I would have basically gotten kilograms would have been 6.054 kilograms. And I guess technically you could do it that way. I should say mass in kilograms. But it's just an odd thing to have your answer be such a small decimal in kilograms when there's a unit that's more appropriate. A way to think about that is like, you wouldn't measure how far away another city is in like inches. It's just silly. Just like you wouldn't measure a room, the length of a room in miles, right? So this is a more appropriate unit than kilograms. So that's why I said to put it in grams from the very beginning. All right, practice 2. I'm gonna walk you guys through a big chunk of this to help you figure this out. But let's start off. They say a cup of water has a density of kilograms per cubic meters and a mass of 236.6 grams. Again, so they give us grams, and here they give us kilograms. The units don't match. We got to do some math to begin with, but it's not that bad. Find the volume of the piece of metal. So let's just kind of backtrack here, right? Remember, our flux capacitor says that density is mass over volume. So if I was to cover up, I want volume. If I was to cover up volume, I know that volume equals mass over density, okay? And up here, they gave me a mass, and they gave me a density. Here's the problem. Units don't match. Let's make it match. You're going to be a lot better off converting this density, which right now is 1,000 kilograms to 1 cubic meter, converting that to grams per cubic centimeter. And so I'm going to use the picket fence method again. I want grams, so I start with grams on top. What do I know about grams? Well, I know that every 1,000 grams makes 1 kilogram. What do I know about kilograms? Well, they told me my density is 1,000 kilograms to 1 cubic meter. What do I know about cubic meters? I know that 1 cubic meter from the last problem is 1,000,000 cubic centimeters. All right, look, my cubic meters cancel out, my kilograms cancel out. And check this out. You may not know this, but 1,000 times 1,000 is actually 1,000,000. So really you have 1,000,000 divided by 1,000,000, which is just 1. So it turns out your new density is just 1 gram per cubic centimeter. That's going to make your life a lot easier. All right, so I want you to use that density instead of that density and that mass to figure out the volume in cubic centimeters. Now you have cubic centimeters, so it should be a lot easier to do. Go ahead and pause the video and check back when you're ready to check your work. Okay, one little caveat on this one. Since you have 236.6 grams and you're dividing by technically a fraction, it is technically a fraction because it's like 1 gram per 1 cubic centimeter. So I wrote it like that. Well, remember when you're dividing by a fraction, you could just flip, you can multiply by the reciprocal. So flip and multiply. So this is really like saying 236.6 grams times 1 cubic centimeter over 1 gram. Grams cancel out. So really this is just 236.6 times 1. So it ends up being a really easy problem once you realize that your density is just 1. This is actually kind of why the metric system is pretty good, is the density of water is just 1. Makes things really simple when in the units grams per cubic centimeters. So very, very useful. All right, let's go on to example 3. And this is a different type of density. This is called population density. And for population density, we tend to use this basic flow where density equals population over area. Instead of mass over volume, it's population over area. And so let's read this problem. It says the U.S. covers an area approximately 3.8 million square miles, with 7.1% being covered by water. Oh, okay, we'll think about that in a little bit. With a population of over 320 million people, what is the population density of the U.S. in people to habitable square miles? So we need to do, what do they want to know? They want to know the population density. So they want to know density, population density. Sometimes it just means density with a little subscript P to say population. So is population over area. And let's color code this. So my population, that's people. And my area is this, but they gave me this caveat. So let's talk about area real quick. We know that the area is 3.8 million square miles, but we're not going to use all percentage of that, right? We're going to take away 7.1%. So if I was to take away 7.1%, I mean, you could kind of just do 100 minus 7.1. You get 92.9%. So really, to find out how much land I have to take 3.8 million square miles and multiply it by 92.9%. So what does that look like as a decimal? That would look like 0.929. So let's go ahead and do that in our calculator. When you do 3.8 million, I would actually just, you could do 3.8 and just know you're dealing with millions, or you could do 3.8 and then followed by 5 zeros, right? Because that would be 3.8 million, see? So I'm going to just do the 5 zeros in my calculator. And I get that the area is actually 3,530,200 square miles. All right, now we have a correct amount of area, right? Because they were kind of giving us more than we really deal with because people aren't living on top of the water. Well, maybe they could with a boat or something, but they're wanting us to just use the land area here. So let's go ahead and find our population density. We know that the people is 320 million. And now we know that the area is 3,530,200 square miles. I should have put P for people here. So what's my density? I simply divide these two, and you can plug this all in the calculator, or if you want, you could just cancel out zeros real quick. Like I have 2 zeros here, I could cancel out those 2 zeros, just so it's a little bit less to plug in the calculator. But when you plug that all in the calculator, you should end up with about 90.65 people per square mile. A square mile is pretty big if you think about it. But 90 per square mile seems like it's kind of a lot of people to live there, but it's really not if you think about it, especially since in the cities we have a lot of people living on top of each other and stuff like that. So that's pretty decent. All right, let's go to the next page. All right, From Indian Lakes put on a show at a venue in Sacramento last night. That's the name of a band, by the way. Maybe I might be aging myself, but the rectangular floor of the venue had an area of 200 square meters and was packed shoulder to shoulder with fans. Interesting. The band wants to know how many people were at last night's show. They estimate that on average, each person takes up a circular space with a diameter of 0.8 meters. Since the floor was packed, they assumed these circular spaces were tightly packed together in rows and columns. Okay, let's think about that real quick. So they're actually giving us a big hint. They're saying it's in rows and columns. You might think like, oh, if I'm putting a bunch of circular spaces together on the floor, it would look like that. But that's not what it says. It says rows and columns. So really, you could think of these as a rectangle. Or I'm drawing a square here where like there's a person, there's a person, there's a person, there's a person, there's a person. So even though they say they're like a circular space, there is some gap in there. So really we could think of this as a square because of the fact that they're telling us to organize it in rows and column. So let's think about what the area of one person is. Well, that would just be like one square. So one person would take up 0.8 meters squared, which is 0.64 square meters. All right, let's come back to that in a second. Let's see what they want to know. Estimate how many people were at the From Indian Lakes show based on their assumptions. Okay, let's just remember that population density. We use this flux capacitor. And if you think about it, what they're really asking here is they're asking for population. So we want to do density times area. And we kind of have a density here, but we're going to have to kind of structure it just right. So since population equals density times area, I'm going to go ahead and say population equals density times area. Population equals density. Let's remember this, that density has to be written as people over area, people over area. So I have here that I have one person per 0.64 square meters. Now that's a weird way to write a density but it doesn't matter. It'll work for us. And we're going to multiply that by our area, which we know up here is 200 square meters. And if we multiply that, square meters are going to cancel out, and we could get an estimate of our population, which is 312.5 people. Now, I don't think there was a half a person there, so we could just like round up, and I would say there's approximately 313 people. I mean, you probably would really estimate it to be more like around 300, but that works. Okay, fun problems here, guys. Lots of fun. The density of water is 1,000 kilograms per cubic meter. Most wood floats and has an average density of 641 kilograms per cubic meter. Most metal sinks and has an average density of 9,157 kilograms per cubic meter. Writer sends it to explaining why you think one floats and one sinks. And you could look up densities of other objects that float or sink and see if you could figure out what the rule is here. Maybe if you've taken a science class, you already know. All right, see you guys on the next video.